And this room was virtually unusable by the tenants prior to the refurbishment, just because it was very difficult to get into comfortable temperatures in the winter. We've got an alleyway on the side over there, so a lot of heat loss out into the alleyway. We've got a very big window behind us here. Single glazed, you can imagine a lot of heat loss through that window. We've got high ceilings, we've got large wall areas. And there was a chimney over here as well in the original room. So what have we done in here? Well, first of all, this partition wall here was taken out. As you can see in this photograph here. That allowed us to fully insulate the front wall of the house, but making sure that we didn't get cold bridging in by the windows. We also made sure that we insulated right up into these floor joist areas, so we didn't have cold bridging between the walls. 100mm of insulation has been put there onto metal stud work, so there's a small air gap behind it. That's the way Kingspan recommend you fit that type of insulation on external walls, solid walls, because of rain and damp coming through the walls. So that's been done there. Over here, actually, because it's a protected wall, it's in the alleyway, we've used plaster dabs to secure the insulation boards. And you can see the Kingspan board being lifted into position here. This room sits over the cellar. We've insulated between floor joists. We've just pushed board up into kind of push fit there, and then we've covered that up with a layer of plasterboard. So we added another couple of 100mm of insulation under the floor to try to reduce the air changes in the property, the ventilation heat losses. We've put a piece of chipboard on the floor, very cheap, very easy, just to seal, make the airtight the floor, and then we've put polyurethane foam all around the edges of the floor as well to really work hard to reduce the ventilation heat losses in the property.
The main key thing is the external wall has been dry lined. It's 80mm phenolic with 12.5mm plasterboard, so you're looking at 92.5mm thickness. So the existing plaster would have been removed. We applied a parge coat to seal the brickwork, and then the dry lining has then been put on a metal frame. So we've got a 25mm cavity between the existing brickwork and the back of the insulation. One thing to do as well, we have to insulate the reveals here for the cold bridging. So you insulate here as well. This junction here with this wall. So this isn't the full thickness. This is 30mm. Triple glazed windows, argon filled. So you've got 18mm distance between this pane and the middle pane, and another 18mm distance between the middle pane and the outer pane. And they've got warm spaces as well. So normally you would have aluminium spaces. The U value on these windows is 0.9, so they're about 50% more efficient than a window that complies to current building regs. We've specified high efficiency appliances and fitting. So we've got a shower here. It's got a flow rate of 6 litres per second, which is around about half of what a normal shower flow rate would be, which is 12 litres per second. So we'll be saving hot water there. The bath has it's got a slightly lower volume, so if you were to have a bath, you wouldn't have as much hot water in the bath. And we've got click taps as well on the wash basin. Now, originally this had an electric shower, so because we put a solar hot water system in, we want to maximise the hot water that we're going to be generating from that system, so we put in a shower that obviously utilises the water from the solar thermal system. When we took the plasterboard off, we only found there was about 25mm of rock wool in there, so it's pretty much uninsulated. Now what we did here, we wanted to utilise the full depth of the roof rafters, because we wanted to get it down to a U value of about 0.1. So because this is a bitumen, it's got a bitumen roof liner originally, so we replaced that with a breathable roof membrane, which allowed us to utilise the full depth of the roof rafter. So you don't have to have a ventilation gap at the top of the put phenolic insulation, friction fitted in between the roof rafters, and then over that we then put the Kingspan phenolic boarding, another 80mm plus the 12.5mm plasterboard. So you've got 180mm phenolic. That's got down to a U value of about 0.12.
Unusually, we've got a combination boiler for the gas heating. I say unusually because usually when you've got solar thermal heating, you almost always find that people have got a standard boiler with a standard hot water storage tank. We've got the solar heating panels on the roof. We've got our pump station here. This is a drain back system rather than a sealed system, so when it's cold and the pump's not running, the fluid from the roof will drain back into that vessel there, and that avoids any issues with freezing liquids on the roof. Over here we've got our storage tank for the solar hot water, and then the water will pass through to a solar mixing valve. If that tank is already up to temperature and doesn't require any heating, it simply bypasses the boiler and goes to the taps. If as today it's going to need boosting, it will be fed into the boiler, and the boiler will apply additional heat to that water. Above the boiler we've also got an interesting device. We've got a gas saver device. Well, it's a condensing boiler, of course, so it's recovering some of the energy from the flue gases just in the condensing boiler. The gas saver unit just really improves that by another couple of percentage points. It's used basically to preheat the hot water. I said a minute ago the hot water was sitting at 22 degrees centigrade, and there has been no sunshine, I don't think, this morning. How it's reached that temperature because the gas saver is heating the water.
Insulating the external walls, it's always preferable, if you can, is to externally clad, because one, you don't get the disruption that you do with dry lining, and also it addresses those cold bridging issues that you have to address if you dry line. Obviously the downside of it is that it does change the appearance of the building. We decided for Tyndall Street that we didn't want to change the appearance of the front of the house because it would have stood out from the rest of the properties. But externally, at the back of the house, we didn't feel we were losing anything from an architectural point of view. So as you can see, we've got external cladding on the back of the house here, and it's 100mm phenolic, and then there's a render applied over the phenolic, which is a polymer render. The insulation is mechanically fixed to the masonry. One problem with this is obviously with the polymer render is that the temperature when you apply it has to be above 5 degrees. So we've had a few problems the last few months finding a day to actually carry out the works.
We calculated the energy use for the house before the measures were carried out. The house had single glazed windows, very little in the way of insulation. The house has a cellar. There was no insulation between the cellar and the front room, making that room very cold. We estimated that the fuel bills for this house would be somewhere in the region of around about £2,500.